Okay, students, now let's move on to our next definition. It's a potential difference. Now, for the electric current to flow, the most important condition is potential difference, as I mentioned. Let's talk about the potential difference. What exactly is this potential difference? Technically, potential difference is what? Work done to move a unit charge from one point to another point in an electric circuit is called potential difference. Work done to move a unit charge from one point to another point in an electric circuit is called potential difference. So what is this unit charge and electric circuit? Students, unit charge means, let's say 1 coulomb charge. Unit means 1. So 1 coulomb charge. Let's say 1 coulomb charge. Electric circuit, we will discuss about this electric circuit later. For the time being, you just remember electric circuit as a path. For the electric current to flow, they need a path. So here electric circuit is the path. Now let's understand what is the meaning of this definition. Work done to move unit charge from one point to another point in electric circuit. Let's say suppose I have point A and this is point B. If I want to move 1 coulomb of charge from point A to point B, I have to spend energy. I have to do the work. The amount of work done or the amount of energy spent to move 1 coulomb charge from point A to point B is called potential difference between point A and B. Students, remember one thing, potential difference exists always between 2 points. So let's see this definition one more time. Potential difference between point A and B is defined as the amount of work done or the amount of energy spent to carry 1 coulomb of charge from point A to point B. So potential difference. Say suppose between these 2 points, if I want to move Q coulomb of charge. Now let's generalize this statement. Instead of 1 coulomb charge, say suppose I have to move charge Q from point A to point B. So definitely we have to spend energy. Let's say to carry this Q coulomb of charge from point A to point B, I spend W joule energy, or I have to do W joule of work. Now students, to carry this Q coulomb of charge from point A to point B, we spend W joule. Now if I ask to carry 1 coulomb of charge, how much work we have to do or how much energy do we need to spend? It's W by Q. Unitary method. If Q coulomb of charge, if I want to move Q coulomb of charge from point A to point B, I have to spend W amount of work, or I have to spend W amount of energy, or I have to do W amount of work. If I want to move 1 coulomb of charge from point A to point B, the amount of energy we need to spend is W by Q. And just a while ago, what did I say? To move 1 coulomb of charge from point A to point B, the amount of energy spent is called potential difference. Now the amount of energy spent to move 1 coulomb of charge is this much. So this is potential difference. Potential difference between point A and B. So potential difference between point A and B is the amount of work done to move 1 coulomb of charge. 1 coulomb of charge, not 2 coulomb, not 3 coulomb, not 4 coulomb, only 1 coulomb of charge. So Q coulomb of charge needs W amount of work or W amount of energy. So 1 coulomb charge needs W by Q amount of energy. So W by Q amount of energy is the potential difference between A and B. So potential difference have a symbol V. Like all other physical quantities have a symbol, just like that our potential difference also have a symbol. We'll be denoting potential difference by the symbol V. So if this is a potential difference, I can write this quantity as W by Q. So V is equal to W by Q. So here is the mathematical definition of a potential difference. So potential difference V equals W by Q. So every physical quantity has a SI unit. So there is a SI unit to measure the potential difference. So potential difference is measured by a unit called volt. Students, you can compare the potential difference with the water levels. We can understand potential difference with this water tank analogy. Here we have a two tanks. You can see one tank is full of water and this another tank is empty. And this two tank is connected by a pipe. There is a valve which regulates the flow of water. If I open this pipe, students, imagine what should happen. Naturally, the water will flow from this tank to this tank, and this flow continues till the water level equalizes in both these tanks. The moment water level equalizes in both this tank, the water flow stops. Now, students, water flows. Water continue to flow if there is a water level difference in the tank. If there is no water level difference in the tank, no water will flow. Just like that, in electricity also, if there is energy level difference, the current will flow. We can understand this. Here you can see we have a conductor. If I tilt this conductor containing water, the water will flow like this. If I tilt the conductor this way, the pipe, if I tilt the pipe containing water, the water will flow this way. If I tilt the pipe containing water, the water will flow this way. Now why the water is moving this way and this way? You can see this end of the pipe is at the greater height from the ground. Means we can say this end of the pipe is at a higher potential energy. And this end of the pipe being lower in height have a lower potential energy. So in nature, everything tends to move from higher to lower. So because this end is at the higher potential energy and this end is the lower potential energy, so water will flow from higher potential energy to lower potential energy. Now in this case, this end is at the higher potential energy and this end is the lower potential energy. So water will flow from higher to lower potential energy. Just like that, in case of electricity, if I have a conductor, say suppose this is a conductor, if I can maintain the two ends of the conductor at different potential energy level, we can make the current to flow. So that's the most important condition for the current to flow. Potential difference. Potential difference means potential energy difference. So here in case of a pipe, it was gravitational potential energy difference. But here in this case of electricity, it's not a gravitational potential energy difference. It's an electrical potential energy difference. If I take a conductor and if I make the conductor, if I tilt the conductor this way, we should not expect the current to flow, because tilting the conductor left and right will not make the current to flow, because this will not create the potential difference, potential energy difference. That was possible in case of a gravitation. So tilting the pipe makes the water flow because of a gravitational potential energy difference. Now, if I want to make the current to flow through the conductor, I have to maintain the two ends of the conductor at different electrical potential energy difference. Now, to maintain the two ends of this wire at a different electrical potential energy difference, we need a device. The device that can create the potential energy difference across the end of this conductor. And that device is a battery. So battery, if I connect the two ends of this conductor with a battery, that battery can create the potential difference across the end of the conductor. And the moment there exists a potential difference across the conductor, the current starts flowing through the conductor. Students, now we understand what is potential difference and what is the importance of the potential difference. Potential difference is a physical quantity that we denote by a symbol V. So here V stands for potential difference, W is the amount of work done, and Q is the amount of a charge that we want to move from one point to another point in an electric circuit. So we have a SI unit of potential difference as a volt, V. Voltmeter. Students, voltmeter is a device. Voltmeter is a device to measure the potential difference. In our daily language, we call this potential difference as a voltage. We are very much familiar with the term of voltage. So technically, this voltage is called a potential difference. Now, this voltage or the potential difference is measured by a device called a voltmeter. Student, let's understand what is the meaning of 1 volt potential difference. As I mentioned earlier, potential difference exists between the 2 points. Let's say I have a 2 point, say A and B. If I say the potential difference between these 2 points is 1 volt, what does it mean? Let's see. Mathematically, potential difference equals V is equal to W by Q. I want to define 1 volt potential difference. So in this V, in place of this V, I'll write 1 V. And this W, that's a work, so I'll write 1 joule. And this Q is the charge, I'll write 1 coulomb. So 1 volt means 1 joule per coulomb. It means 1 volt means 1 joule per coulomb. That means suppose from point A to point B, if I want to carry 1 coulomb of charge, I have to spend 1 joule of energy. If I say potential difference between 2 points is 1 volt, it means 1 volt means 1 joule per coulomb. 1 volt means 1 joule per coulomb. So, potential difference between 2 points is 1 volt. It means to carry 1 coulomb of a charge, we have to spend 1 joule of energy. Now, if I say between 2 point A and B, there is a potential difference of a 2 volt. What does it mean? It means 2 joule per coulomb. Now, to carry 1 coulomb of charge from point A to point B, I have to spend 2 joule of energy. That's what we mean by potential difference of a 2 volt between 2 points. Say suppose between 2 point A and B, if I say potential difference is 10 volt, what does it mean? It means 10 joule per coulomb. Now to carry 1 coulomb of charge from point A to point B, I have to spend 10 joule of energy. So that's what we mean by a potential difference of 1 volt between 2 points. So water tank analogy. About the water tank analogy, we have already discussed. So 2 tank, one is full of water, another one is empty. There is a valve regulating the flow of water. If I open this valve, the water starts flowing and this flow continues till there is a water level difference. The moment the water level equalizes, the water flow stops. Just like that, if the two ends of the conductor, there is a potential difference, the current continues to flow. If the potential difference ceases to exist, the current flow stops. So the most important condition for the current to flow is the existence of a potential difference. So about the cell and battery, I already mentioned. If you want to maintain the potential difference across the end of the conductor, you need a device that will help you maintain the potential difference, and that device is the cell or the battery. If you connect the cell or the battery across the end of this conductor, that battery will maintain the potential difference for you across the end of the conductor and makes the current to flow. So students, I hope you understood what is potential difference and what is its importance.